Hello, Pre-Cal, and I've got a quiz review video for you here. So I'm all ready with my calculator in degree mode, and I'm going to start by finding the area of this oblique triangle. And this is a great triangle to start with because before I can even find the area of this triangle, I first need to find the height. And in order to do that, I need an angle somewhere. And I'm going to go after this little angle right here. I'm just going to solve the triangle for the angles, and then I'll be able to find the area. So we're given here a side, side, side presentation. And with a side, side, side presentation, we need to utilize the law of cosines. So let's label this as A, B, and C, which makes this little a, this little b, and this little c. So let's go after angle A first. So A squared equals B squared plus C squared minus 2BC cosine A. Remember the helpful hint that I gave you? Whatever letter is up front, the corresponding angle will be on the back side. So let's plug in what we know. So A is 7, so 49 equals B squared, which is 144, plus C squared, which is 225, minus, and my helpful hint is to use parentheses, so 2 times B times C times cosine A. So obviously, since we're trying to determine an angle, we're going to be using an inverse cosine here. So let's follow order of operations and let's combine some like terms here. So 49 minus 144 minus 225 is going to give us negative 320 on the left. And on the right is 2 times 12 times 15. So that is 24 times 15. That's 360. So minus 360 cosine A. Divide in order to get cosine A by itself. So we're anticipating this to be an acute angle. So we have 320 divided by 360, and we will take the inverse cosine of that number. So we find angle A is 27.3. Angle A, 27.3. Let's go ahead and find angle B, and now we can utilize the law of sines. So now we've got 7 over the sine of 27.3 equals, and let's go after angle B, so 12 over sine B, cross multiply and isolate sine B. So sine B will be 12 sine 27.3 all over 7. So let's go ahead and plug this into the inverse sine. So inverse sine of this fraction, I'll utilize my fraction option on the calculator. We zoom in so maybe you can see a little better. Not sure why that's not showing up. One more time. There we go. So inverse sine of 12 times the sine of 27.3, close that parentheses, go to the bottom, over 7, and then I'm going to close the whole entire set of parentheses, and I'll get my B angle. My B angle is 51.8. So angle B is 51.8 degrees. So if angle A is 27.3, angle B is 51.8, 180 minus 27.3 minus 51.8 gives me a missing angle of 100.9. So I just used the law of sines, law of cosines, and the triangle inequality, not inequality, but triangle interior angle sum theorem in order to solve the remaining parts of this triangle. So I am still after the area. So to find the area, I need to know the height. The height can be found by dropping an altitude down. Remember, an altitude is always going to be perpendicular to the lowest side, which in this case is the base. And in this case, the altitude is living in the exterior, and that's okay. So let's keep thinking about what we learned in geometry. We need to know the supplement of 100.9. That's the remote interior angle theorem. So what is 27.3 plus 51.8? That is 79.1. This is 79.1. So now we can find the height of this triangle by utilizing the sine function. So here is the angle in question. The A, remember, is this side, which is the hypotenuse of the little green right triangle. So the sine of 79.1 is equal to the opposite side, which is h, the height that we're after, over the hypotenuse, which is 7. Cross multiply, and we finally know h. This is a really good involved problem that really assesses everything. So 7 times sine of 79.1, the height is 6.87. So now, if the area of every single triangle you've ever known is 1/2 base times height, we're using that right now, 1/2 the base, which is 12, times the height, which is 6.87. So we end up with 6 times 6.87. Here we go. That is 41.24. So we have a total area of 41.24. That would be square feet for this particular triangle. That is finding the area of an oblique triangle using first the law of cosines and the law of sines, using a sine function in order to find the height, and then utilizing 1/2 base times height. Converting polar coordinates to rectangular coordinates. So first of all, visualize where this point, remember this is a location on the coordinate plane, visualize where this point would be. So if this is r and this is theta, if we were to graph this, it would be back down in the negative direction 2/3 pi, so 1/3, 2/3, and then on this particular pole, 1, 2, 3, 4, 5. So we are way downtown in quadrant 3. So we should be getting a negative negative when we convert to rectangular. You have to know that x equals r cosine theta, y equals r sine theta. So we're going to use that, use these r and this theta in order to convert. So x equals 5 times the cosine at negative 2 pi over 3. So once again, the cosine right down here at negative 2 pi over 3, think unit circle. So that would be here. So that is going to be back 1/2. So that's 5 times negative 1/2. So our x coordinate is negative 5/2. The y coordinate, I'll put it right here. Y equals 5 times the sine of negative 2 pi over 3. So that is down root 3 over 2. So 5 times negative root 3 over 2 gives us a y coordinate of negative 5 root 3 over 2. So there's our x, there's our y, converting to rectangular coordinates, both negative as we anticipated in quadrant 3. On the bottom of the page here, I've got a polar equation. Let's convert this polar equation to a rectangular equation. I gave you some legal moves to remember in class. The first one is make good substitutions, which we were just using substitution there. And also, maybe it might be smart to either square both sides. But if we were to square both sides here, we would end up with r squared, which would be great since r squared is equal to x squared plus y squared. But if we square the right-hand side, it's going to make a mess. It's going to make 9 sine squared. We don't know anything to do with that. So it makes more sense in this situation not to square both sides, but to simply multiply both sides by r. And that is a legal move, which does give us r squared, and which, if we use the commutative property here, we get 3 times r sine theta, which we know that r sine theta is equal to y. So this allows us to make some substitutions here. So now we've got x squared plus y squared equals 3y. And we can see now that this is the equation of a circle. Let's change it to standard form by completing the square. Move that 3y over. So x squared we don't need to do anything with. Y squared minus 3y. 3, you're like, oh my gosh, Andrea, it's an odd number. Okay, big whoop. 3 divided by 2 is 3/2. Square that, we get plus 9/4. Add the 9/4 to both sides, and now we can factor. So x squared is staying, and then factors of 9/4 that add up to 3, they are simply 3/2 times 3/2. So we get y minus 3/2 squared equals 9/4. This is our answer in standard form. So r equals 3 sine theta. If we look at the graph, and remember, if we want to graph on the polar plane, we have to be in polar mode. So let's change, and also we have to be in radian mode. So we're going to change to radian, and we're also going to change to polar. So now I'm able to graph, so let's go to the polar graph. So r equals 3 sine theta. Close those parentheses, and we got a circle. Remember, if we hit zoom 4, we're going to get a nice square scale. So where is our circle? Our circle has a center point at 0, 3/2, and has a radius also of 3/2. So here we go, r at 0, 1.5, and a radius of 3/2, and that is correct. Use your calculator to check your work whenever we do these problems. Now we're going to convert from rectangular to polar. So converting to polar, we're given the x, given the y. Remember, x equals r cosine theta, y equals r sine theta. And in this case, we need to use the fact that tan theta equals y over x. So visualize where negative 4, 4 is, back 4, up 4. Think about it. This has to be in quadrant 2, and we've got a 45-degree reference angle here. So this is 1/4, 2/4, 3/4. But if we have tan theta equals -1, then we need to consider tan inverse of -1 equals theta. Do recall that the tangent inverse only lives on this side, so we have to think of it, and let's name it 2 ways. But I am looking to see that you understand how to use the inverse function. So let's extend this pole into where the tangent inverse does live, and of course this would be negative pi over 4. So theta is negative pi over 4. And what would r be? R, of course, r squared is equal to x squared plus y squared. So r squared equals 16 plus 16. R squared equals 32. Square root, r equals plus or minus 4 root 2. So if we're going to give this polar coordinate in the most correct form, this will be down pi over 4. So that's going to be our theta, r theta. So down pi over 4, but instead of going forward 4 root 2, we're going to be going backwards. So negative 4 root 2. This is the best answer because this is utilizing the inverse function properly. All right. Oh, the second answer. Let's also do it a second way. So if we do it the second way, we can also say over to 1, 2, 3/4. So 3/4 pi and then up forward 2. This is the best answer. This is the second best answer as well. Y equals 12. Visualize y equals 12. We know that y equals 12 is a horizontal line. So think about that. It's a horizontal line. We are going to change it to a polar equation. So if we have y equals 12, so what is y equal to? Y is equal to r sine theta. So let's make a substitution. So r sine theta equals 12. And I'm kind of running out of room here. And then in order to be a polar equation, we want r in terms of theta. So we're going to divide both sides by sine theta. So we get r equals 12 over sine theta. This is a perfectly wonderful answer, or you can say r equals 12 cosecant theta. Both of those are correct. And if we check it on the calculator, when we graph it, we should see the horizontal line at 12. If I can get it to focus. So let's go to the polar plane. So we can do this one, r equals 12 over sine theta. Go to the fraction. So 12 over sine theta. Let's close that and graph. And I'm going to have to zoom out because obviously 12 is not on here. So let's change the window and let's give it a y min of -1 and a y max of 13. And we should be able to see it. There it is. If our max value is 13, then we definitely have a line going through y equals 12. That is 12 over sine theta. Last problem. Convert to polar. Think about this equation. This is a linear equation with a y-intercept at -5 and a slope of 2. Let's convert it to polar by making two quick substitutions. Y is r sine theta and x is r cosine theta -5. So our goal is to solve for r in terms of theta. So r sine theta minus 2r cosine theta equals -5. In this particular situation, r is the GCF, bring it to the front. R times sine theta minus 2 cosine theta equals -5. Divide both sides by this entire quantity, sine theta minus 2 cosine theta. Both sides. We can only cancel if we're able to factor. Our answer is r equals -5 over the difference of sine theta minus 2 cosine theta. R in terms of theta. That is your polar equation.